Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give more examples related to trigonometric identities. So the first one is we're going to evaluate the following questions without using a calculator. Alright, so first question, question A. So what we have is we have cos 170 degrees times cos 70 degrees minus sine 170 degrees times with sine 70 degrees. So this actually has the look of cos A, cos B minus sine A, sine B. And I hope that you can recognize that this is just cos A plus B. So this is the formula for the sum of two angles related to cosine function. So now what we can do is we can write this expression given here as cos 170 degrees cos 70 degrees minus sine 170 degrees sine 70 degrees will be equal to cos 170 degrees plus 70 degrees. And this is just cos of 240 degrees. Since the question is asking you to not use a calculator, and we need to start thinking about the position of this angle and also some sort of information related to special angle, which you have seen in the previous subtopic. Okay, so let us start by sketching the angle and the position of it. So it will be somewhere here. This will be 180 degrees and you continue further on, so this will be 240 degrees. Now, as I have mentioned earlier, we know that we can work with the reference angle. So the reference angle is this one. So this is the reference angle. And you should know that the reference angle in this case is going to be 60 degrees. So this is going to be 60 degrees because then 60 degrees plus 180 degrees will be equal to 240 degrees. So based on this angle, I hope you can recall the special angle triangle which we have done in the previous subtopic, which is this one. When you have 60 degrees on this and this one is 30 degrees, and then you have this length of 1, side 3, and the hypotenuse is going to be equals to 2. So because the value of because cosine is on the third quadrant, therefore the value of this is going to be negative. Remember, add sugar to coffee. For the third quadrant, only tangent is going to be positive and the rest are going to be negative. Therefore, what we can do now is we can write down the value of cos 240 degrees is going to be equal to negative of cos 60 degrees. Okay, and based on this, you can get the value of cosine 60 degrees. Cosine 60 degrees is 1 over 2. So final answer for this is negative 1 over 2. Okay, next we are going to move on to answering question B. So I'm going to erase this slide. Okay, I'm going to erase this slide. Okay, so for question B, we have something that is complicated, but actually if you recognize this is, you can call this as tangent A. This is something else which is tangent B. 1 plus this is tangent A multiply with tangent B. So This comes straight from having the formula of tangent A minus B. Now why is it minus? Because we follow the sign on the numerator part here, so we have a subtraction. So here we consider that subtraction process. Now therefore what we can do is we can simplify this complicated expression into something simpler. So I'm going to write down tangent 107 degrees minus tangent 47 degrees over 1 plus tangent 107 degrees multiplied with tangent 47 degrees. This is just equal to tangent 107 degrees minus 47 degrees. And based on that, you will get that the answer is tangent 60 degrees. And again, we can sketch the position of 60 degrees. So tangent 60 degrees. So this is the diagram. So 60 degrees is going to be on this. This is our angle, which is 60 degrees. And this is also the reference angle, which is 60 degrees. Okay. And next, in order to find what's the value of tangent 60 degrees without using a calculator, then what you need to do is you need to consider the special angle triangle which you have seen in the previous subtopic, where here you have 60 degrees and 30 degrees, and the length of this are going to be 1, 3, and 2. Now, we know that for the first quadrant, every function here is going to be positive. The result of every function, such as tangent or sine or cos, everything is going to be positive on the first quadrant. Therefore, we don't have any issue to do with this. So we just write down straight the answer based on this right angle triangle. We can say that tangent 60 degrees is sec 3 over 1, which is just equal to sec 3. Alright, now let's look, continue on. Okay, we're going to continue on with the last example of this subtopic. So in this example, we're going to prove the following identities. So the first one is question A, where I'm going to consider starting with the left-hand side. Okay, so consider the left-hand side. So we're going to start off with having sine x plus y over cosine x multiplied with cosine y. Now, what we can do is you should be able to recognize that this is the sum of two angles with respect to sine function. So we are going to expand this. So when we expand this, this will become sine x cos y plus cos x sine y over cos x cos y. And then we can separate the terms here. So that will be sine x cos y over cos x cos y plus cos x sine y over cos x cos y. Next, what we can do is we can cancel out the similar term. So for example, this can be cancelled, and this also can be cancelled. Now, what we've got left is sine x over cos x, and this is the definition for tangent x. So this is equal to tangent x plus, then for this one you have sine y over cos y. So this is again the results in having tangent y. So there you go. We have managed to prove that the left hand side is equal to the right hand side. Okay. Next, we're going to move on to the last question here, question B. So allow me to erase the ink on this slide. Okay. So suppose that I will start off with considering the left-hand side of this equation. So I'm going to consider the left hand side. So we have tangent theta plus cotangent theta, and this may be equal to I don't know, I'm just going to express then in terms of sine and cos, because here we've got something that is related to sine. Cosecant is actually 1 over sine. Okay, so what we are going to do next is, I think what I will do is I'm going to write down this in terms of something that involves sine. So that would be sine theta over cos theta, and the definition for cotangent is the reciprocal of this one, so it will be cosine theta over sine theta. So that is my starting point, and I'm going to add up these two fractions together, and to do that I need to find a common denominator. So what we're going to do next is we're going to multiply this cosine theta and sine theta. Therefore, on the top part is going to be sine squared theta. Sine theta with sine theta is going to be sine squared theta, plus cos theta times with cos theta, you will get cos squared theta. Now, I hope you do recognize that this is going to result in a very simple answer, which is 1. So this is the trigonometric identity. So sine squared theta plus cos squared theta is equal to 1 over cos theta sine theta. Now, you know, throughout proving a certain trigonometric identity, you might, you know, come across, or you might get stuck, so, and you don't know how to proceed. So what I can do, or what you can do, is actually you can sort of look on the right hand side. For example, here you can see that cosecant is actually can be simplified as 1 over sine 2 theta. So cosecant 2 theta here is just 1 over sine 2 theta. So I know that I need to turn this into something that is related to sine 2 theta. Now, if it's not quite obvious to you, maybe what you can do is you can try and write down what is sine 2 theta. So sine 2 theta is just sine theta plus theta, which we have seen in the previous video, and this can be expanded as sine theta cos theta plus cos theta sine theta, and this can be simplified into 2 sine theta cos theta. So this is the definition, this is the formula or the equation about sine 2 theta, something that you have seen in the previous video. So if you look at what you have over here, you have cos theta sine theta, which is this one, cos theta sine theta. Okay, so what you can do is we can substitute, or we can replace this with sine 2 theta over 2. Okay, so what we can do is, I hope you can see that, therefore sine theta cos theta is going to equal to sine 2 theta over 2. So sine 2 theta over 2. Okay, and then this result can be substituted into here. Okay, so now I'm going to write down the result here. So therefore this is equal to sine 2 theta over 2, and this is something that can be simplified as 1 times 2 over sine 2 theta. So this is actually equals to 1 over sine 2 theta. It's similar, it is a similar thing. I'm just, you know, changing the position of 2 and 1. So it is the same thing. And we know that 1 over sine is cosecant. So therefore it becomes 2 cosecant of 2 theta. So there you go. You have managed to prove that the left hand side is indeed equals to the right hand side. Alright, thank you very much for watching. I'll see you in the next video.